All right, here's your video for 2.5. Um, so the big things that we're supposed to be learning today is determine the values of the 6 circular functions from the coordinates of a point on a circle centered at the origin with any radius r. So really this means we're just moving away from the unit circle. So we've always been dealing with just the unit circle, but as you know, not every circle does have radius of 1. So we're going to go ahead and focus on these ones now. So I did these at the end of the last one. That's just there for more practice for you. But we're just going to go straight here. Okay. So the only information we have is that theta is an angle in standard position whose terminal side contains the given point, and that we're supposed to find the values of the 6 circular functions, meaning sine, cosine, tangent, cotangent, secant, and cosecant. Okay. So the first thing I'm always going to do is I'm going to draw this out. So if I have the point 1, 5, that point is right here. Okay, that's A. All right. And all I really know about theta is that theta is the angle in standard position, meaning it has a initial side along the x-axis, and it has a terminal side right there, and theta is the angle in between them. Okay. Well, so here's how this kind of pops out as a drawing of a triangle independently now. Oops. So now all we know is that this side length across the bottom here is 1. Okay. This point was at the point 1, 5. So the bottom length has to be 1. And it is, it clearly is, it's 1. And then this way length has to be 5. Now, things we don't know theta, and we do not know our hypotenuse. I'm going to go ahead and call it x, if that's okay. All right, but this is a 90-degree triangle, which tells me that I can use the Pythagorean theorem to find x here. So I know that 1 squared plus 5 squared would have to equal our x squared. So therefore x equals the square root of 26. Okay, that's 25 plus 1 is 26. That's going to be the square root of 26. Okay, well, that's great. X is the square root of 26. Awesome. I'm going to go ahead and put that guy in here. But I still need to be able to find the 6 circular functions. So we are looking for the sine of theta, the cosine of theta, the tangent, the cotangent, the secant, and the cosecant of all of these. So remember, sine is always your opposite over your hypotenuse. Well, 5 is my opposite, and my hypotenuse is the square root of 26. Now, we really don't like these. You really should rationalize this to be 5 root 26 over 26. Okay? Cosine is your adjacent over your hypotenuse, so that would be 1 over the square root of 26. Again, you really should rationalize that denominator, so this really should be the square root of 26 over 26. Now, our tangent with a picture is very easy to do. If you were just thinking, oh, it has to be sine over cosine, this is actually a lot harder problem. But if you draw the picture, tangent is actually really easy to do because tangent is just your opposite over your adjacent, which of course is just 5. Okay, so it's a lot easier in those cases if you have the picture all set up. Now remember, cotangent is just tangent flipped upside down. Well, that's going to be 1/5. My secant is going to be my cosine flipped upside down, and I'm actually going to look before I rationalized. It's easier to deal with it before you rationalized. because now we're going to do 1 over the square root of 26. The reciprocal of that is the square root of 26 over 1. Well, that's just square root of 26. It's easier than trying to do this and then re-rationalize. Because if you flipped that one, you would have ended up with 26 over the square root of 26. Then you'd get 26 root 26 over 26. And those are all going to cancel anyway. So it just makes it a lot harder. It's more steps. So if you go back to your original here, flipping it's much, much easier. And then, of course, your cosecant is also your sine reciprocal. So this is going to be the square root of 26 over 5. That's all 6 for this one. Okay, I want you guys to try this one out on your own with this example. So go ahead and pause the video and try that one out. So you guys had a chance to do that one. Again, the big thing I want you to know here, you have to draw the picture. So if we've got our picture, we know that we go over 1, 2, 3, 4, 5 and down 2, 3, 9. So here's our point. So the reason this matters is because now our triangle is actually looking a lot more like this. Okay, so I'm going to go ahead and pull my triangle out so we can think about that a little bit better visually. Okay. So then we know that we've got so there's our theta. And this one's kind of strange too, as I should talk about this. So because of where this point ends up, we're actually really going to want to deal with a reference angle instead, which is kind of a strange thing. So I'm actually going to back it up and say that we actually want to deal with the triangle that is created here. So that's going to be 5. And this one along the y-axis here is going to be there, and that's going to be -9 or 9. And then we'll do this one instead. And so then the theta that we're working with is there. Okay. So then you would just have to go in and say, okay, the sine of theta is going to be equal to the opposite over my hypotenuse. Well, that requires knowing what my hypotenuse is. Okay, so remember, my hypotenuse is going to equal the square root of both of my sides squared. I believe that comes out to be the square root of 106. Okay. So then your sine is your opposite side divided by your hypotenuse. Again, we should always rationalize. So 5 root 106 over 106. Okay, I will list all of the answers out for you, but I'm not really going to talk through how I got any of the others. The answer for cosine should be -9 square roots of 106 over 106. I think that is technically reducible. I think those are both divisible by 3, but I could be wrong. And then tangent ends up being -5/9. Cotangent is -9/5. Secant should be negative square roots of 106 over 9. And finally, your cosecant should be the square root of 106 over 5. Okay, I do want you to notice which ones are positive and negatives. We are in the fourth quadrant, which means the only thing that should be positive here is cosine, which worries me because I have it as sine being the positive one. I will make sure that this is updated when I post the notes, because I'm I'm not sold on that being a correct answer. So I'll get back to you guys on that one. So, here we go. Alrighty. Cosine equals 1/3, and I know it's in quadrant 1. All we know is that theta is the angle in standard position, and that we need to find the 6 circular functions. So again, I'm always going to start with a picture. We know it's in quadrant 1 because it told us so. Okay. So that puts theta here. Okay. And if cosine is 1/3, that is telling us that our adjacent side is 1 and our hypotenuse is 3. Okay. And then this is the one I don't actually know, and I'm going to call it B because A, B, and C. Okay. So I know that B is equivalent to the square root of 3 squared minus 1 squared. So the B is going to be square root of 8 or 2 square roots of 2. If you don't remember how to get that, this is 2 and 4, 2 and 2. So this 2 gets out, this 2 gets stuck. Okay. Alright, so we've got that one. But we have to find all of them. So keep in mind, they actually gave you one of them. So we need our sine, our cosine, our tangent, our cotangent, our secant, and our cosecant. Okay, this is everything we're going to need. But it actually already gave us, honestly, 2. I would say it actually gave us 2. Because it gave us cosine being 1/3, which means it's also just by default giving us that the secant is 3, because that one's going to be the reciprocal. Okay, so then sine just needs to be my opposite side over my hypotenuse. So this one's going to be 2 root 2/3. My tangent is supposed to be my opposite side over my adjacent side. My adjacent side is 1, so this one's actually really easy. It's just 2 root 2. Okay, so I'm going to go ahead and do my cosecant next, actually. So that's going to be my sine flipped upside down. So it would normally be 3 over 2 root 2. Or in this case, it may be easier to use root 8 on the bottom at first, because now we need to rationalize. So this is going to be 3 root 8/8. But I already told you that root 8 is indeed 2 root 2. And I say that that might be useful because you can actually reduce this one. This one should actually be 3 roots of 2/4, because that 2 kind of kills that one. Okay, and then cotangent ends up as 1 over 2 square roots of 2. Same thing, it may be easier because you're going to have to rationalize it to leave it as square root of 8 for a minute. So go ahead and multiply that in, and you get the square root of 8/8. Again, we talked about this. 2/8 is the same as root 2/4. Okay, so there's all the answers for those ones. We talked about this a little bit last time, about unrationalizing things. Okay, because I'm seeing a square root of 91 on top and a 91 on bottom, this tells me that this denominator has actually been rationalized. Okay, so first of all, we're in quadrant 4, so it's going to be down here. And cosecant, remember, is 1 over the sine. Okay, and I'm going to go ahead and unrationalize this. So this is supposed to be negative 10 over the square root of 91 is equivalent to my 1 over my sine, which means my cosecant should actually be the square root of 91 over negative 10. Okay, so I know my sine is my y value, so I know that this is going to be negative 10. Okay, I know that my angle is somehow in here. Alright, and I know that my hypotenuse is the square root of 91. So really all that I don't know is this a value over here. Okay, so again, we need to have all 6 of our functions listed out here. All right, so sine we kind of already talked about here because we talked about how 1 over sine is this. So sine would be negative 10 over the square root of 91, right? Wait, hold up. I'm writing the wrong thing. It's right there. Silly me. The square root of 91 over 10, and that one should be negative. Again, we're in the fourth quadrant, so the only one that should be positive is cosine. Okay, and that would require knowing what a is. So remember, a is going to be equal to the square root of the square root of 91 squared minus negative 10 squared. Okay. Uh-oh, what happened? This comes out to yet another answer, which I don't think is what it's supposed to do. So let's see if I can figure out where I went wrong here. I think it's because my hypotenuse is not my longest side. 10 is bigger than the square root of 91, which is a problem. So I think I actually gave you guys a bad problem. Double check my notes from last year here. Oh, silly me. 10 is my hypotenuse. I just have it backwards. So hypotenuse is 10. There we go. Silly me. Okay, so then a is actually equal to the square root of 100 minus 91, which is 9, which is 3. Okay, so then your cosine is going to be 3/10. And then I'm going to go ahead. We already know cosecant, right? We already were given that. Since I did cosine, I'll go ahead and do secant also. That's going to be 10/3. Tangent is going to be our adjacent, our opposite over our adjacent, which is going to be 3 over the negative square root of 91, which rationalized should look like that. And cotangent then is the negative square root of 91 on top and a 3 on the bottom. Okay. All right. The only thing I'll say with these ones is that you need to recognize that, hey, there's a 1 underneath those. Okay. So I will include C, D, and E on the completed notes, but those are really just intended to be more practice for you guys. So there's those. If you have questions, let me know. And yeah, so you guys should get your homework done, and I'll see you guys on Friday.